Here, so the objective of this study is to understanding the nutritional characteristic and how much the nutritional available after the cooking effect in the chestnut. Because we understand if we doing the cooking, there's something compound is volatile, is all lost during the cooking process itself. We took 4 variety, Judea, Longan, Martinia, and Rebolda. For Judea to the Martinia, it's in one set, one orchard, but of course it's different tree. But for Rebolda, it's only one tree in the different orchard, and we receive all the sample from the Sebugal. And here is the pre-cooking. So the first we selected chestnut with the water. So if the chestnut is floating, it's the rotten or the merketiu. We not use the rotten one to the study, and we pick 20 pieces of the good chestnut. We give the numbers and also do the code for replication. It's 1, 2, 3 till the 5, and after that we do the colorimetric to measure how the color value is with these tools, and also the scale of the chestnut for each pieces, and then also the scale, the balance. And here is the cooking methods we applied in the labs. There are 3, boiled, roasted, and dehydrated. For the boiled, we do the temperature 90 degrees Celsius with 30 minutes, but it's not 30 minutes on the 90 degrees. It's 30 minutes from the 0 to the 90 degrees. It's the total time to the cooking chestnut during the boil. And it's without anything. We not slice or we don't peel. It just puts on the water. And the roasted one we do at the 230 degrees, 25 minutes. It's similar from the 0, but before it we do the preheating. So 5 minutes first before we put the chestnut inside the oven. We took this temperature for preheating the room on the oven, and we use the cross slice on the chestnut. Each chestnut will have the cross slice, and the last treatment is the dehydrate. Dehydrate with food cabin for kitchen. It's just small one, not the big one, and it at the 30 degrees at 4 hours, and it the peeling first. So why we use peeling and the other notes? Because this is already food cabinet. It's clean, and also when we do dehydrate, it's normally to evaporate the water. And if we still using the skin or shell of the chestnut, the water will be blocked. The shell will be blocked the evaporate water, and the sugar and the other content will be stuck on the shell. So it will be bad for the nutritional quality. And here is the result analysis from the Konica using the color spectrometric. If we see in here, is actually there have some point dot in here. It's located for the coordinate exactly the color it is. So this is a P1 for the first location, and the P2 plus 2, and PT is plus 2, and so on. So the P5. So this is the formula I use to analyze the number of the color we receive from the Konica, and we're running on the R programming using the pipeline, and it's automatic to analyze it. And this is the apparent. So this is the median, this is parity, And this is the code of number color. So when you put this code, it's exactly direct you to the color we have in the lab. And here is the physical result analysis. This is still not complete because I still missing the spectroscopy aspect ratio to determine the dimension of the kernel each. But at this moment, we have already the average and the median score in here. It's not too small, but it's also not too big. It's in median. It's yeah, we can see on the market during the harvest. Here is the nutritional analysis from the fresh. So this nutritional analysis in fresh we use as the control to look the effect on the other cooking method. So first the boil. In the boil, all this parameter, carbohydrate, fat, and protein is going down, but the SGFA or short chain fatty acid, it's still high in here. And during the roasted, the protein is increasing. If we compare to the fresh one, and also the carbohydrate is increasing. It's normally, if we give the high temperature or the high thermal processor, the protein should be denatured. So we took this note. Is this kind of the normal condition, or is we have wrong the experiment during the cooking? And this is dehydrate. During the dehydrate, normally all this content, the carbohydrate, fat, and protein, is still on the degrees, but not too much. It's only like 1% if we compare to the fresh one. So we compare to the other study from the Gonzalo. So this is the boiled one. It's with our result. We can look into here. I compare it's Judia Longan and Martinia, but because Reboda is still not used on the cooking method, and look, if we look to our study and compare to the Gonzalo study, the difference is not too much to this old indicator in the boil. The difference only on fats and also in the content of the protein. However, the Gonzalo study is in the PDO area, the protected destination organism for the chestnut. So maybe probably the environment have a rule in here to have more content on this protein also in the fats. And we look the roasted. So the roasted one is also similar. So it means in Gonzalo's study, this kind of the situation is normal. When we use the roasted one, the carbohydrate and protein is increasing with the fresh one. So it's not wrong study, but not wrong the method, but it's normal study. The problem is why and how, and it will be answered in the next feature analysis. So the feature analysis we will continue is first is the resistant starch content and vitamin, specifically in tocopherol group, alpha, beta, and so on. Because the vitamin of tocopherol is indicating which adipose tissue for increasing the immune system in the good microbiome, and also the pelopenic compound and antioxidant activity will be analyzed. And after that, we can make sure from the statistical analysis, PCA, principal component analysis, with two factors, variety and the cooking method. So we can see which variety is the best with the cooking methods, like Martinia maybe is better on the roasted, or maybe Reboda is better with the dehydrates. And thank you for the Sebugal, for the sample we received. And also this research is funding from the Cultivar and so on. And thank you.